Hi friends, welcome back to my channel. I hope everyone is doing well and you guys are watching our newly posted videos. We are creating lots of good videos for you. Today we are going to solve another interesting string coding problem on Leetcode 3227 vowels game in a string. So this is a medium complexity string coding problem on Leetcode. So we are going to understand this problem with couple of examples today, and we are also going to implement our Java solution to solve this coding problem. If you haven't already subscribed to this channel, please consider subscribing to this channel now. It really helps and supports this channel. Here we create videos to help others in their coding and Java interviews. So let's start with the problem statement first, then we will take a look into the examples. Alice and Bob are playing a game on a string. You are given a string S. Alice and Bob will take turns playing the following game where Alice starts first. On Alice's turn, she has to remove any non-empty substring from S that contains odd number of vowels. On Bob's turn, he has to remove any non-empty substring from S that contains even number of vowels. The first player who cannot make a move on their turn loses the game. We assume that both Alice and Bob play optimally. Return true if Alice wins the game and false otherwise, and the English vowels are A, E, I, O, U, right? So we know that. So this is what the problem statement says. The age dart length will be between 1 to 10 raised to 5 inclusive, which means that the given string can be very big, right? And it contains lowercase English letters. So let's understand this problem better with some examples. So in the first example, lead coder is the string that is given to us. So Alice will start playing first, right? So what she can do, she can take any substring of that has odd number of vowels. So here you can see that she is taking a substring lead co. This substring she is taking, and it has uh, odd number of vowels, right? E, E, and O. So it is 3 vowels. So she removed that. So now the string becomes DER, right? Now Bob has to take a substring and remove it where there is even number of vowels, right? You can see even number of vowels. So now in this case he will just remove D, right? So if he removes D, then it has 0 vowels, which means that it's an even number of vowels, correct? And then the string will be ER. So far you understood this, right? Now in the ER, it contains only one vowel, right? E is the vowel. So Alice will remove the whole string and Bob will have empty string. Now he cannot do any move basically, right? And it means that Alice will win, right? So this is one example. This is another example where BBCD is given to us. Now in this case you will see that the first Alice has to play. Now she has to remove any substring which has odd number of vowels. Now here there are no odd number of vowels, right? So it means that she cannot move basically. So it means that she will lose. So you will return false. So this is what the problem statement says. The first player who cannot make a move will lose the game basically, correct? So this is we already saw this example and this example just now, right? Now if there is other string Java and Python, then for Java Alice will win. How Alice will win? She has to remove the odd number string, right? So let's say she is removing the odd number. So she removed JAV. It has one vowel, so she can remove it, right? It's a substring. Now it will be left with only string A. Now can Bob proceed with the string A? He should uh, it should contain even number of vowels. So now there are no even number of vowels in A, right? This is odd number because it's only one vowel there. So it means that Bob will lose and Alice will win. So you will return true. Python, this is another string Python, right? So in Python there is a vowel here, right? That's the only vowel. So what Alice can do is Alice can remove this whole string actually, right? The whole string she can remove because it has odd number of vowels, right? And then Bob will have uh, he will be left with empty string, so he cannot move, and it means that Alice will win. So it will be true, right? So with these couple of examples, did you notice one pattern that Bob can only win if there is no vowel in the string? Okay, so this is the example where Bob can win because there is zero vowels here, right? Zero vowels. So it means that allies cannot move basically, right? Cannot make any move, right? So in that case, allies will lose and Bob will win. So it means that whenever there is any vowel in the string, it means that always allies will win. I'll repeat this sentence. This is very important. If there is any vowel there in the string, then allies will always win. Why is that? Because she can always uh, take out the basically vowels, and then the like for example here, right? Let's demonstrate it with some example. So now here you will see that there are 1, 2 and 3 uh, and O, right? So there are 4 vowels here, right? So now she can basically she can always win whenever there is a vowel. Why? Because let's say she takes out the string, right? Then Bob will be left with on, or she can take out the whole string basically. She can take out the string until this part. So they already demonstrated it, right? This part, and then der will remain. So in der bob can take either r or or d, because he has to choose the string substring with even number of vowels. So if he chooses r, and the string will be left with de, right? So allies will choose de now, right? Because it has odd number of vowel. So always allies will win if there is a vowel present in that string, right? So let's just consider that there is a simple string where you have only one vowel, JAV, right? So allies will take the whole thing and she will win. If you put one A here, still allies will win. Why allies will win here? Because she will take this string JAV. Now A will be left for Bob. Now Bob cannot move basically, because Bob has to remove 0 to 4 like that, right? Even number of uh, even number of vowels. Now again Bob will lose. Let's say there is one more A here, right? One more A here. Still Bob will lose, right? Still Bob will lose, because in that case allies will remove the whole thing, right? Because it's odd number. So always Bob will lose whenever there is a vowel present there. So this is the important point. So it means that all we have to do to solve this problem is to find out in the string if there is a vowel present there, right? If there is a vowel, always allies will win. If there is no vowel like this one, then Bob will win, right? So I hope you understood this with this example, why allies will always win when then there is a vowel, correct? So, and if there is no vowel, for example AB, for example you have CD, right? If your string is CD, then allies will lose, right? Because she cannot make any move. If you put any vowel here, any vowel, then she will delete this, means she will remove this, she will win, right? If there is one more vowel there, still she will win. Why? She will remove this DEA. Now Bob will be left with E. Now he cannot move, still she will win, right? If there is another vowel here, still she will win, because she will remove the whole thing now, right? So as long as there is any vowel present there in that string, always she will win. Okay, so this is the concept to solve this problem. So let us go ahead and take a look. So the code itself is very simple once you understand this concept. Okay, so this is the is vowel method. So it's just a boolean. So this is a helper method, basically we call in Java as a helper method. So we just check if that character is A, E, I, O, U. If any of this character will return true, and we will use this method in our main method. Does allies win? So string S is given to us. We will convert this string S into character array by using toChar array method, and we will check if this character is a vowel. If you find any vowel in that string, always allies will win, so you will return true. If you come out of this for loop, it means that there is no vowel present in the string, and then you will return false. In that case, allies will lose, right? So this is it basically as the code goes. The code is very simple. Once you understand the concept, then we'll run it and make sure it works correctly. So these are couple of test cases. I added some of my test cases. So these are the test cases for Python true, because there is one vowel here. In this case Java again true, because there are two vowels here, right? So we are getting correct answers. Leetcoder, again there are vowels, so it will be true. Submit this code to the Leetcode, make sure the code gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 55.19%. This number keeps changing. Let's try to resubmit this one more time, and still the number is same. So this is how you can implement this code, and you can solve this coding problem on Leetcode. 3227 vowels came in a string. So let's talk about the algorithmic complexity for this code. So the time complexity for this code is order of n, where n is total number of characters in the given string. So this is the worst case, where you don't have any vowel, you have to go through that complete string, right? Then it will become order of n. What about the space complexity? The space complexity for this code is order of 1. This is also called by many people as constant, because we did not use any extra space to store anything here, right? We don't have any linked list or hash set or hash map or any other data structure here that stores the information. So it means that it's a constant on space. So this is how you can analyze this code. So I wanted to show you the logic, how we can approach and solve this problem. So it's just important that for these kind of problems you just write down couple of strings and try to think about this thing. uh, so it's like many times it's very simple logic that you can just apply and solve these kind of problems. So I hope you understood this concept with these couple of examples that we have demonstrated in today's session. And if you like this whiteboarding session with examples, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription really helps and supports this channel. Here we have more than 500 different varieties of coding problems solved and explained for you. Don't forget to check out the playlist. All important problems are waiting for you here. That includes graphs, matrices, binary search trees, binary trees. Different data structures also you can learn here, such as tags queues, priority queues, min heap, max heap. There are problems that discusses recursion, memoization, dynamic programming, and how to use them to solve different problems. So do check them out. They will definitely give you a good prep for your interviews. And keep learning, keep coding, keep solving more varieties of coding problems. And thanks for watching this video, and have a great day ahead.